I'm Altimish Mohammed and this is Project Luna. I initially developed Luna to address a very common issue that folks like myself tend to face, which is eye strain while working in a dark environment. A great solution for reducing this eye strain is to gently backlight displays in work areas. This decreases the perceived difference between bright light sources and your darkened surroundings. I wanted more control over this, especially when watching movies or gaming, so Luna became a way to enhance entertainment experiences. There are many other solutions for dynamic bias lighting, however they all suffer from rather severe shortcomings. Luna is essentially plug and play, low latency, low processing overhead, highly extendable, follows IoT principles, and is extremely configurable. It's wireless, so the LEDs behind the screen are controlled remotely, has basically one frame of latency, and will run at your refresh rate of your display. It's pretty scalable, with agnostic broadcasts allowing for a many relationship between client and servers. It supports multi-monitors. Some of the things that you can configure are adjustments for any aspect ratio or media format, the ability to ignore banners and sports graphics. It works regardless of LED placement. There are brightness adjustments for different RGB channels, hue balance adjustments, calibration for activation thresholds across all channels based on luminance as well as hue. There are great optimizations for gaming applications, such as a built-in downscaler, LED persistence timeouts. There are 4 different methods for optimizing transmissions based on perceived color differences by the human eye, such as a complete implementation of all Delta E standards. It's extremely optimized for your network. There's no real impact on local network performance or online gaming. Luna has 5 display modes, the first being a primary screen capture, the second being for a configured screen, third a broadcast of a static image. Then more interestingly, it's completely scriptable, so you can use a sequence of images with interpolation levels and frame rate. You can also define your own animations using a simple scripting language, also with interpolation and frame rate specified. There are also some handy configuration modes that allow you to black out or to remotely configure the server and strip for brightness and LED count on the fly. This means that you won't actually have to remote in to make changes to the server. This is a fairly generic platform that's open to extension. It supports extensive logging, which makes it easy to troubleshoot and understand exactly what's going on. A custom config parser makes specifying settings simple, as well as provides really helpful and specific error messages due to a very elegant config sanity checker. There's also a visual debugger, which is massively helpful when setting up for the first time. Finally, there's full command line support so that you can build your own frontend and pipe into the core framework. I really just started with the basic goal of grabbing the screen content and averaging the RGB values over certain areas, setting those to the corresponding LED on the strip. Along the way, I discovered tons of nuances and had to provide many methods for configuring the solution for different types of media and screen arrangements, as well as optimizers for human vision. On the client side, a combination of Win32 calls occurs for grabbing the screen contents. The resulting images are processed with a library of custom C++ functions. All the image processing is largely independent of existing libraries. Also, interestingly enough, there's almost no object-oriented stuff used. You can see a video on my channel for more information about that. Server side, it's a basic Python implementation. It's quite robust, it's fast, it's resilient to packet loss and large volumes of I/O, and it easily launches when the Raspberry Pi itself powers on. Speaking of the Raspberry Pi, the hardware stack comprises of your home computer. It talks to a Raspberry Pi over your local network, and the Pi itself is connected to a bunch of addressable LEDs, which can be of any standard type. I, along the way, used a soldering iron as well to burn as many LEDs as possible. Things like breadboards, a 5-volt power supply, jumpers, and all the other little fiddly bits that we need to connect these things together. I do indeed love traditional desktop dev. Visual projects like this make me want to both end it all and appreciate the good things. The most frequently asked question that I get is, does it work on PlayStation? Currently, no, but that was beyond the scope of this project. Seeing as it's written almost entirely in basic C++, you should be able to quite easily port it over to something like an Arduino microcontroller that inlines and processes HDMI signals. I also have ideas for a simple, dynamically generated frontend. The wireless nature of this project means that it should be very simple to create control interfaces that exist completely remotely and perhaps online. The system is also generic enough to allow for outdoor cinemas and powerful lighting solutions to use the exact same tooling. It's not limited to behind display setups. You can deploy this anywhere, ambient lighting in galleries, car showrooms, dining venues. I hope to provide plug-and-play kits to anyone interested. Feel free to get in contact. Project Luna in its current state far exceeds what I planned to accomplish when I first started this. Scripting, debugging tools, configurability, and overall performance goes beyond what I imagined I'd achieve this year. It definitely is a success, and I'll continue enjoying it in my own living room and workspace every day. Thank you.